So I wanted to make a quick explanation video for Gauss's method, which is just sort of dropped into your textbook on page 413. But the legend is that Carl Friedrich Gauss was really advanced as a young boy. And he had a teacher that to occupy him, hopefully for a good amount of time, because he was working through everything too quickly. The teacher gave him the question, what is the sum of every number from 1 to 100? And the legend is that young Carl came back with the answer quite quickly in a way that really surprised everybody in the room, and his teacher was astounded, and everybody's like, wow, this guy really did his thing on this one. So we're going to call it the method, Gauss's method. So what I'd like to do is break down, because it's actually a method that works for any number of adding up any number of positive integers. So what the legend is that Gauss, he said, well, he started to think about it, and he thought about it like this. Well, I'm going to add up all the numbers from 1 to 100, right? So 98. So with all this stuff in between. So what he ended up realizing was, wait, what if I do 1 in 100? That will give me 101. How about 2 in 99? That'll give me 101. How about 3 in 98? That would also give me 101. So what Carl did, or Gauss did, was he thought about how many of those pairs there would be. What he realized, though, is that the middle pair would be 50 and 51. And so from 1, 2, 3, all the way up to 50, that means, and then this is the second part of that pair, 51 to 100, there would be 50 pairs of 101. So all he had to do was multiply those two numbers, which is actually just 50, 50, right? 50 times this one will give me 50 hundredths, times this one will give me just 50 units. So he came back to his teacher and said the answer is 5,050, and his teacher was astounded. The thing is that what Gauss's method gives us is a method for when we're doing a summation of any number of first positive or n positive integers. So what we could do if we're trying to, in my summation notation, if we're starting at 1, so it only works if we're starting with 1 up to any number, and we're just adding up those numbers. So nothing's happening to that thing we're plugging in. It's just that. All we have to do is take half of the number of numbers, as Gauss noticed here, 50 was half of 100, and multiply it by 1 more than the number of numbers. So it's often simplified this. Of course, you may say, well, Mr. Tennant, it makes more sense for me to think of it this way. Well, that's fine, but it's usually written this way. You can see that they're equivalent. So if I were to ask you what is, for instance, what would be the sum of the numbers 1 through 20, all we would have to do would do 20 over 2 times 20 plus 1. This one's not too bad, because 20 divided by 2, I could just simplify that to get 10. 10 times 21 is just 210. And if you don't believe me, we could try doing it out here, which you may say, I believe you, why are we going to write all this out? Well, hopefully it just proves that our method works. Wow, 14, 15, 16, 17, 18, 19, and 20. So 1 plus 2 is 3, plus 3 is 6, 10, 15, 21, 28, 36, 45, 55. Okay. 55 and 11 is 66, 78, 91, 105, 120, 136, 153, 171, 190, 210. Wow, it worked. We ended up at 210, just like Gauss's method. So we have this shortcut now that we could always use whenever we're trying to add up any number of numbers. You could try this at the dinner table. Say, hey, ask me to add up any number of numbers, like 1 to 50. You could just go, okay, bam. What's 25 times 51? Well, that's kind of a tough example, but you could probably figure it out if you took some time doing some mental math. But you could say, hey, I don't know if anybody here knows what's the sum of all the numbers 1 to 100 is, and you could break down your new method. Hope everybody's doing well, and hopefully this gives you some context to how we're able to use some of these core concept equations, formulas for special series that are on page 413 of the textbook. Talk to everybody soon. Have a good one.